Hello and welcome to this lesson on resistance in series and parallel, which is part of the electricity topic in GCSE AQA physics. So if we've been successful and we've learnt in today's lesson, we should be able to understand how to calculate total resistance in a series circuit, understand how to calculate total resistance in a parallel circuit, and experimentally measure total resistances and compare them to theoretical values. So in this lesson, we're going to look at the following part of the GCSE AQA physics specification. Required practical activity 15, look at combinations of resistors in series and parallel. So, what do we know when we're looking at the total resistance in series and parallel? Well, when designing or analysing circuits, complex combinations of resistors are common. Now, to perform calculations, so for example, to find a suitable fuse to protect a circuit, it's easy to find a value for the total resistance of the circuit. Now, the total resistance is the single resistor that is total to that complex combination, and we can calculate the total resistance for both series and parallel circuits. Now, in a series circuit, we know that the total resistance is equal to resistance 1 plus resistance 2 plus all the other resistors in series. Now, this makes sense as the more resistors in a row, the more collisions there are between the charge carriers and the metal ion. So therefore, the greater the impedance to the current, the greater the total resistance. It also means in a series circuit that the total resistance is larger than any single resistor in series. So to work out the total resistance in series, the resistor values can just be added together. So for example, if you had a 10 ohm, 20 ohm and 15 ohm resistors, the total resistance is 10 plus 20 plus 15, which is 45 ohms. So like we said before, in general, R total is equal to R1 plus R2 plus R3 plus Rn. So when you're working out the value of resistance in series, just add the resistor values together, which is shown in the following example. Say we have three resistors in series, 20 ohms, 30 ohms and 40 ohms. Well, the total resistance is 20 ohms plus 30 ohms plus 40 ohms, which is 90 ohms. So the total resistance is larger than any single resistance. Now, when resistors are in parallel, the following equation is used. 1 over the total resistance is 1 over R1 plus 1 over R2 plus 1 over Rn. Now, this makes sense as the more resistors in parallel, the more possible paths the current must travel down. So the less likely it is for the metal ion and charge carrier collisions, the lower the resistance. So this means, in parallel, the total resistance is smaller than any single resistor. So for example, if we have a 10 ohm, 20 ohm and 15 ohm resistor in parallel, we can say 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So it's 1 over 10 plus 1 over 20 plus 1 over 15. So we then find the common denominator in the terms, so that's 60, so it's 6 over 60 plus 3 over 60 plus 4 over 60. So we then change the denominator, all the terms of that common denominator. We then add the numerators of each resistor, keeping the denominator the same, so it's 13 over 60. So you can also do this with the calculator if you want to as well. After this you flip the numerator and denominator, so it's 60 over 13, 4.62 ohms. So if we look in the following example, we've got 10, 20 and 40 ohm resistors in parallel with each other. So 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So it's 1 over 10 plus 1 over 20 plus 1 over 40. So it's 4 over 40 plus 2 over 40 plus 1 over 40. So that's 7 over 40. That becomes 40 over 7. So it's 5.7 ohms. And as a logic check, the total resistance is smaller than any single resistance. So, using the laws of resistors can allow you to determine the overall resistance of complex circuits. So for example here, you can turn the 10 and 5 ohm resistors which are in series to 15 ohms, so you can consider that to be 15 ohms in parallel with 30 ohms, so we get our overall value of 10 ohms. And similarly here, you can work out the 10 ohm and 10 ohm in parallel with each other are 5 ohms, so it's 8 ohms plus 5 ohms in series, which is 13 ohms. So to clarify, in series, RT is R1 plus R2 plus R3 plus Rn, so the total resistance in series is greater than the individual resistance of a resistor. So as there are more resistors in a row, the greater the impedance of the current, the greater the total resistance. Whilst in parallel, 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over Rn. So the total resistance in parallel is lower than any individual of a resistor, because the more there are possible paths for the current to travel down, the less likely it is for the metal ion charge carrier collision, the lower the resistance. Now, if we think about this in terms of an investigation for a required practical, you need to observe the total resistance of different combinations of resistors in an electrical circuit. So you need a multimeter and many resistors of different ohmic values, and wires and crock clips as well. So you would retrieve a multimeter, which will act as both a measuring device and a power source, set the multimeter to the 200 kilo ohm setting, and place the appropriate resistors in the correct configurement, and then measure the resistance with the multimeter. So to summarise what we've looked at in today's lesson, in series, the total resistance is equal to R1 plus R2 plus R3 plus Rn, whilst in parallel, 1 over the total resistance is 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over Rn. So if we've been successful and we've learnt in today's lesson, we can understand how to calculate total resistance in a series circuit, understand how to calculate total resistance in a parallel circuit, then experimentally measure total resistances and compare them to theoretical values. So thank you for watching this lesson on resistance in series and parallel, which is part of the circuit electricity topic in GCSE AQA Physics. Thank you so much and have a lovely day.